What's the voltage now? 5764. Okay, these are the 1 millivolt for 10 milliamps heading. This is on the 5 millivolt scale per square division. Both of them are set like that. So the top is power coming out of the battery. These spikes here are what's being returned to the battery. So right there's the center line. So everything above that line is what's coming out, and just these little peaks here on the bottom are what's being returned. So I'll show that here. There. See, the bottom is what's coming out of the battery, and the top is what's going back in. Just a bit more on the bottom, a little bit brighter. Zero mode again. So there, it's you can see. Top is what's coming out, and bottom is what's going back in. And here you can see the zero line. Right here on the bottom here is what's going into the battery at that voltage. And that's the voltage running the circuit. So all those LEDs are lit, plus the battery's still getting current being charged. And here's the analog meter. So I'm going to take this off here now. There, I just took it off. I'm going to try to turn it back on. Takes a bit to get it to run again. There, it's on again. So that's running all those 6 LEDs. I'm still putting a charge back into that battery, or into that one. So, take this off, put it just on the LEDs. There, that's the circuit running on its own. Hi guys, so I've been pretty busy here, so I haven't been in here much, but this has been running. It's been 6 days on here. So this started at 2669, fully charged, and this one was 57.52. It's got over a volt now. Let me just turn on the scope here quickly. 1 millivolt for 10 amps setting on these. zero out. Okay, so anything above the line here is what's coming out of the battery. This is what's being returned. And anything below the line, center line, is what's going into the battery here. So go like this. So I got all these LEDs here. The bottom ones here, they're all paralleled. That's what comes out when they're lit. You'll see those on. When it's going back in, it'll light the top ones. These three, they're all paralleled. So they're all lit. Here's the gauge. Let me just take them off. See the gauge move. Hard to get it to go, but when it goes. There. And then I'll put this one on this side, on the output. So that's the output going through that one. At that voltage, 58.92. And that's what's the bottom is coming out of the battery, and the top is being returned. I just want to see here, put this bypass the LEDs. There it's on, and now you can see that's the current. It's stronger because it's not resisting it on the input up here. It's not taking 3 volts away. But I'm going to transfer the power back to the battery now. Okay, I have it hooked up here. As soon as I turn this on, see the light, it's on. See the current. So that's what it's going to draw for current. And just to show the LEDs here, haven't changed anything. The blue ones should light up. That's the power. Not much current. But I'm not going to put it through lights, it's just going to go like that. And run until that one's backed out in a 57.52. Which will take many hours. Probably most of the day. Right, so this has been returning the power back for over an hour now. So back up to the voltage I start with, so anything above that is topping the battery up again. It's into the charging phase of it. 58.64. So got a long ways to go. Many hours to go. Just start cleaning up in here a little bit and let it do its thing. Okay, this has been running for quite a while now. Not sure exactly. Over 3 hours though. 58.23. 26.76. And so you take that voltage, subtract that from that voltage, take this voltage and subtract this voltage from that one, and now you get the voltage in the battery, or in the light bulb, I mean, sorry. And the current right there. Alright, so I'm going to show maybe at the end of this video when I get this voltage here down to like, I don't know, 57.6 or so. Probably lots. I can't remember what it started at. Somewhere around there. And this started at 26.69. So what I'm going to do, I don't know how many people have seen this in my previous videos before, but I've showed it in the past. Or I can take a battery at this voltage, like very close to, like I want the battery to have like 1 volt difference, like the sums of this battery voltage and the other battery bank that I'm going to use. I need it to be about 1 volt or so less. I'm not sure how much current will flow between the two. Like, I don't want to have too much current because it'll produce too much heat and possibly damage something. So what I want, though, like I'm trying to say is, and I want to have this battery voltage about 1 or 2 volts above what I'm going to be doing with these two battery banks combined together. So what I do is I take a bridge rectifier and I can subtract the voltage instead of the light bulb. I can actually charge a second battery bank, well, actually a third one, but charge this one with another one without having them in parallel or in series. You know, you could do that just by adding them in series here, but I just want to show a way that you can actually subtract voltage and charge a battery. You know, like, because if this wasn't a battery, like if you're running a load or something at this voltage, you could actually, instead of wasting it in heat, you can actually put it into a second battery just by subtracting the voltage. The current will flow right through it, but it'll charge it instead of actually, like if you were trying to do that without any diodes, you'd be like putting this battery with the one I'm going to add here in series, which would add to the voltage, which I'm not doing. I'm subtracting the voltage just with those diodes. So I might do that at the end of this video. I'm just trying to get some batteries on the tester, getting it down to the right voltage that I need, somewhere around 29 volts or so. So I'm doing that now. So if I don't do it on this video, I'll make another short video if I have time. Pretty busy though, working every day. So okay, guys, I'm just testing these meters out here. I got it. They're all in series. Going to this light bulb right here from this 15-volt battery. I like to test them just to see where they're all at, you know, just to get a baseline. So you can see the one furthest to the right is a little bit higher than the others. They're pretty close though. It's maxed it out. About an amp, silver an amp. at 15 point some volts here, so these are the meters I'm going to be using in that demo if I'm not pulling more than an amp with the voltages where they're going to be. If I'm pulling more than an amp, I'll have to adjust the voltages on that battery. Where's my paper? Right here. So these meters will be right in here. There'll be one here going to this wire is going to go like this to this one. And then this one's going to go here to this positive. This is the source, the original source battery. That one. This one here is going to be this one. And then there'll be another one here with the bridge here. I'll put a meter in between these two connections. A meter in between these connections. Or not those two. This one and this one. I'll draw it out later where it's going to be. And then this one to here, we'll have a meter in between. This one here to here, I'll have a meter in between. So it'll be 3 meters, just to show the current will be pretty equal. Like as equal as the gauges can tell anyway. But the current flowing through them all will be the same. Okay, this is what you're going to see in the demo here. So this is the high voltage bank, the one that got charged from the source battery when I was running the coils. So originally the power came from here and went to this battery. And right now, the way it's hooked up right here, it's going through the light bulb. So what you're seeing is the negatives are hooked together. Positive is here, positive is here, and the light bulb is just right here. And the power goes straight through the light bulb to this positive. So it's what I'm going to do here as soon as the batteries are ready. I'll be using these 3 gauges like I just showed. And I'm going to run them through the gauge to this one. Like without the gauges, the wire just go from this positive to the AC in on this bridge and out through this AC leg to this positive right here. And the positive from the bridge goes to this one, and the negative goes to that one of this extra battery bank, which is going to get charged. I'll have a gauge here, here, and here on all the positives. So on the positive going into this bridge, like from the battery to this AC leg, there'll be a gauge measuring that current. There'll be one on here going to the positive here, coming out of the bridge rectifier on this AC leg. And then there'll be another gauge here on the positive going into this bank. So that's going to come up here. Just waiting for the batteries to get done. It takes hours to do this stuff. These things are still battery voltage now 26.82, and that's 57.85. Kind of goes high when I first turned the gauge on. 26.81. Started at 26.69. This one was 57.6 or so. I can't remember exactly what it was. But it doesn't matter. I'm way above what I started at here already. And twice the power. There's more than twice the power going into that light bulb. So anything you see that went back into the battery, there was more than twice that going into this bulb. Well, all the power that was going into the battery plus a little bit extra. That's what was going into the bulb. You take that voltage and subtract it, that one from that one, and that's the voltage going in through the bulb with that current right there. I'll be back here with the next demo. So I'm already way above. This will rest that fully charged. Where I started. So should be a while yet. Okay guys, so I've got the batteries have been rusting here for a bit. Got my new battery bank right there. There's the bridge rectifier. All my gauges are hooked up. All I have to do is hook up the last wire to that battery bank, which is some paper. I'll show you on paper, it's easier to explain it. So all the wires are hooked up except for this one right here. So without that connection, no current flows through the system. Even though this wire here is going through the gauge, through the bridge, through these two leads right here to this battery, there's no current flowing yet because this connection isn't made yet from here. Which you can see, it's all hooked up. So the positive out of this battery is right here. Comes right here to this gauge right here. It's pretty rat's nest of a bunch of wires here right now. And where's that? This one right here. See, and then it goes into the bridge rectifier right there. And then that wire comes out right here. Goes into this center gauge. And then it'll go up to the positive right here. And this wire into the battery. So that's all connected. Like there's one continuous loop. Here's the negative from this one. Goes down right here, straight to here. And then the positive wires all over the place here. Take that off, move it under. So the positive from here comes into this gauge right here, and that's the wire I'll hook up to complete the circuit. Right here goes into the battery. The negative is right here, just laying on top here. Goes into the battery, from the bridge rectifier into the battery. And the positive is just running through the gauge, and it goes right here. So I'm going to hook it up now. The batteries have been resting. 29.68 on this battery. This one's 26.79 now. This one's 57.86. So I'm going to turn it on. There. So if I take apart any of these leads on the positive here, the current stops flowing. You can see it's all pretty equal. Because it is actually, the current flowing through the system is always equal. Unless you have another wire that's sharing the current, it always is equal. This one of these gauges is a little bit off, as you've seen in the previous demo when I was testing them. So it's not quite as much current. Well, it's pretty close to what I was pulling with just the light bulb. Actually, it's almost the same. This gauge is just not quite as accurate. But you can see that battery is going to get charged now. And it's just that voltage is being subtracted from this voltage. If this was a lower voltage, there'd be more current flowing through the system because like the higher volt it wants to flow through because it's going to that battery. So this is a very efficient way to. It's not even really a resistor because all it is doing is subtracting voltage from the source. So you can have a light bulb here instead of this battery. You could have anything here instead of that battery. You can see it's getting charged. And you'll see this voltage will eventually rise too. Lighting's not very good in here. Should turn the lights on. $26.69 or 29.69. Let's see here. This might be better. And there, it's a little bit better. So it's probably about 60 milliamps. That's less than what I had transferring with the light bulb. But I'll just leave this play here. I'm going to pause it. I'll leave it go. And I'll be back when I see this keep rising a bit. I'll come back. Hey, that didn't take long. It's already up. So I know that if you didn't have the bridge rectifier, you could just hook all these batteries together and the voltages would equal out. Hey, that didn't take long. You can see how much it's rising. It's only been a couple minutes. So if I didn't have that bridge rectifier in there, and these batteries were in series with this one, there'd be a huge inrush of power going to this battery. Because there's only 1 volt difference or so in between them. Because that battery bank isn't subtracting the voltage from this one. That's why there's no resistors in this circuit at all. And there's only that much current traveling between the system. The only heat generated is what's in the bridge rectifier, which is very small. There's no heat at all. It's cool to the touch because that's a 25 amp rectifier. And this will go for hours and hours yet. So I know this battery's getting charged too. On top of that one, which was the original source battery, which is already, it'll rest higher than what I started. Just to show again, this is the circuit right now. So this battery is that one. This battery is that one, which is 26.8 volts. And this one's 57.82. And this one's 29.7. And any missing voltage there is being lost in the diodes here. which should be a couple volts maybe. Not even, no, be half a volt. Because it's being lost there. And the capacity in each cell is 6,500 milliamps right there, and the same with this. So those cells have the same capacity. The watt hours in these battery banks is quite a bit different though, in the combined banks. So what you're seeing, this voltage here rising, is what was being burnt off in the light bulb earlier. In heat. Now there's hardly any heat being generated. And we're charging that battery also too. And you could still take these two leads right here and hook a load to it, but it has to be at a certain resistance. Now you're burning it into heat, putting it into heat, and you can change this to a load if you want to. But again, you can't have too much resistance, otherwise you're going to pull a whole bunch of current. You don't want to overrate your bridge rectifier or your wires or your batteries. So have to keep that in mind. So I'll be back when it's done with another voltage reading. Hey guys, I gotta get to bed here soon, so I'm gonna be turning this off. This will take hours and hours to do. Probably another whole day to get it down to where it needs to be. And this one's climbing 2972. This one's going to keep charging. It's just the voltage has dropped a couple points because the current that is going in here is really low right now, because that voltage has dropped a bit and this one has went up a bit. So it's narrowed that gap. Ideally, I would have had this voltage somewhere around 29.2 or so. Even 29 would have helped a lot. And if this one was higher, it would be different too. There'd be more current transferring. But as that voltage rises and this one rises and this one lowers, it'll come to an equilibrium where there'll be no more current transferring. Everything will just stop. If this was a constant load, that would be different. Like if I had a load on that battery, this wasn't rising. And same with this one too, you could have a load on it. But that's where I'm ending the video, guys, so hope you enjoyed. So long. Just wanted to demonstrate this because like that, this circuit here is really useful for all sorts of things, because it subtracts voltage. It doesn't really resist current. Like as long as your semiconductors can withstand the current, it's gonna flow. And the bigger the semiconductor, the better, because it doesn't create much heat like that. The more heat you create, that's just losses in the system. Same with your wiring. It's all losses. So if you can do away with the heat and just store the energy or use it for what you want, that's the best way. But anyways, thanks for watching, guys.